Hi, everyone. Welcome to the ONIE status update for 2021. I'm Alex Doyle. I'm the ONIE project lead, and I work at NVIDIA. I always like to start my talks with an overview of what I'm going to be talking about, just so everybody knows what they're in for. I realize I'm competing with other talks and free coffee out there, and I want to make sure that everybody feels like they've used their time wisely. So in this project, I'll be going over in this talk, I'll be going over the role of project lead. There's going to be an introduction, some statistics and thanks. I'll go over the ONIE project goals, talk about what's new since the last project update. There's a minor factor of component upgrades having broken pretty much all of the hardware platforms, but that's not really as bad as it might sound. We've introduced improved emulation, secure boot, and security extensions. And then I'll talk a little bit about future plans for ONIE, including a secure installer and some work that we're doing to move ONIE out of the data center into the network edge and look at maybe adding Wi-Fi support. So what's an ONIE project lead? Well, I've been project lead for the last 3 years. I started out at Cumulus Networks and we got acquired by NVIDIA, so same job, different email. My responsibilities include working on ONIE releases, processing pull requests, documentation, which is a little stale at the moment, doing QA, setting the direction of the project, interacting with the community, and pretty much everything managing a project would require. Now, if you're in this room, you already know what ONIE is, probably, but for the benefit of anybody viewing at home, ONIE stands for Open Network Install Environment. It's a small open source Linux operating system for installing other operating systems. Typically, it's built by manufacturers to support their particular hardware, and then it's installed on the devices that they ship. Typically, it's used on network switches, and it allows the end user to install their choice of network operating system on a switch, and it's become an industry standard for NOS install. So since last year, or the last time I gave an update, there's been over 144 sign-offs of new code introduced. ONIE currently supports over 244 platforms. I'd like to thank all the community contributors. Too many individuals to really list conveniently on a slide. So I just picked the top 10 contributions from these companies here to give you an idea of who's involved with the project. So goals for the last 3 years. If you're familiar with the stereotype of the lazy programmer, that pretty much sums up how I've approached things. And I know if you're not familiar with it, it sounds derogatory, but the reality is the lazy programmer is someone who emphasizes efficiency over just brute forcing things. The goal is to work smarter, not harder. There's only so much time in a day, and you want to make sure you use your resources efficiently. And that's the approach I've taken to ONIE, since I have not nearly had as much time as I'd like to work on it. So a couple of things about the stereotype, if you're not familiar with it. One of the things that comes out of this is knowing that making tasks easier for yourself makes it easier for your end users. There are a number of small commits into ONIE that may not seem like much. Why would you bother automating this? But if it saves the end user a minute, it probably saves me an hour because I'm doing it 60 times in a week. But the big thing out of this is doing it right the first time. Make sure you don't have to do it a second time. If the quality of work is such that you finish it correctly, it's not being dragged out, it's much easier to do things right to begin with. And to this end, I think the biggest value there is setting up your workspace properly when you take on a project. If anybody has ever painted a room, as an analogy, you'll know this to be true, that if you lay down a tarp and you tape off the fixtures, you're doing all this work that just sets you up. And even though you haven't put paint on the wall, and even though your kids will come in the middle of it and say, "Hey, Dad, does Mom know you're redecorating the living room in early American serial killer?" You'll find that they don't get it. But when you start painting, you don't have to draw a perfectly straight line with a paintbrush. And if you spill paint, you're not scrubbing it out of the carpet. So with limited resources, this is what I thought the best value for effort was going to be. So what does that look like in software? Well, mainly focusing on infrastructure improvements. Over the last 3 years, components have been upgraded. Things were getting a little stale. Our kernel now is 5.4, GRUB is 4.02. GRUB is 2.04. ONIE now builds in a Debian 10 environment. There were build problems with it building in Debian 9, and I'm working on getting it into Debian 11. We've introduced the open source tool Dedicated User Environment, which provides ONIE build environments through Docker containers. So this way, somebody on the other side of the globe can be using the same build environment I did when I built the last release. Really helps, reduce the number of errors, although to be fair, some people have had problems running Docker, run into some weird issues, which we're trying to track down, but they seem to be intermittent or very difficult to describe or reproduce. So it should work, but there's always the possibility it won't. And if anybody happens to encounter that, please let me know, because I would love to figure out what's going on there. But basically the idea is to make it easier for everybody, to reduce the barriers to entry, to make it more convenient to work with ONIE. And on top of that, a number of pull requests and bug fixes have been processed. And this is good change, but not all change is good. And the bad news is that currently no physical platforms build with the master branch of ONIE, which is an inevitable consequence of having to upgrade things. This is a pretty standard computer science problem. Newer compilers are more strict. Patches don't apply to new code because they're already in there or the code has changed. Library interfaces change, and so on. And introducing component upgrades into ONIE, everything's interconnected, so you end up with a dependency cascade. It's more work than just adding a new package most of the time. So in order to take advantage of anything on the master branch, manufacturers will have to upgrade their code base to the latest version of ONIE. I didn't see any other way around this, but only the manufacturers know their hardware, their code base, and have the resources to test it and prove that it actually works. But I mean, that said, there is some good news. And the good news is that any platform that built in the last August release of ONIE will continue to build, because we have set up the workspace properly. Docker images are available to provide Debian 9 build environments, and ONIE has a file, ONIE build targets JSON, which is basically a database of every single machine that it builds, what release it built off of, the environment it used to build. So everybody should be able to replicate whatever's out there now. So you don't really lose anything except the ability to make progress on the old code branches. All right, so we put down tarps, we've taped off the fixtures. What does actually painting look like? Well, one of the new things we've added is improved ARM64 emulation. This became a priority because of something I was working on at work. I needed an ARM64 emulator using QEMU. And the QEMU ARMv8A target's been broken for a while. So I was prioritizing fixing that because I thought most of the components were there, which turned out to be true. I'd like to give a shout out here to Shi Lei, which I hope I pronounced that right, probably didn't, from Centec for helping me with this. They pointed me at a BIOS that worked with ARM64 better than anything else. And without that, I would probably still be trying to figure out how to get this to work. So that was a massive help from the community. The ARM64 target currently builds ONIE as you'd expect. It builds the installer ISO. It builds the demo operating system, so you can do the full path of build it, install it, try it out. It could use more testing. I know there's a couple of bugs in that. But my philosophy here is to not let the perfect be the enemy of the good. If I can put out something that is useful and mostly works, that gives everybody a starting point to work with it. Because I know there are plenty of kind people out there in the community who will take a look at the work, investigate it thoroughly, and tell me I've done it completely wrong. And as long as there's a pull request proving me wrong, I am totally okay with that, people. Just be the change you want to see in the world. So that's out there. Now, when you go to run it, if you've used QEMU, QEMU is kind of almost a programming language in the number of arguments it'll take. And it's way too complicated to deal with on a daily basis. So it'd really be nice to have easier emulation. So ONIE now has an emulation directory, which features the ONIE VM sh script, which is a user interface to being able to run both the KVM x86 and the ARM64 targets. If you take a look under there, it'll store some emulation files. There's the QCOW2 virtual hard drive that you can install ONIE onto. If you're doing a UEFI BIOS emulation, it will pull the files for the BIOS code and the BIOS variable storage and put them down there as well. Also comes with a virtual USB drive you can add on to store files between runs, which is really handy if you're constantly blowing away your install. So it's been really nice to use, but it is easier. And when I say easier, you can take it, for example, you could try and run an ARM64 target, give it a UEFI BIOS, install ONIE, and your options would either be running the line at the top to tell the script to do this, or you could type in all the stuff at the bottom, which I just can't be bothered with. But the script does print this out so you know exactly what you're running, and that's, I would like to say, probably more for the benefit of the end users to know what's going on. Part of that's also me being smug every time I look at it and realizing I didn't have to type that. So I enjoy that a lot. Now, adding emulation gives us some interesting options here, because now we know something about the runtime environment. Now, with real hardware, ONIE won't. That's totally out of its scope. But for the virtual targets, the build system can integrate with that and do things like copy cryptographic keys to the right location so they can be picked up at runtime, add a UEFI install script so that if you're in the UEFI BIOS, you can just run the script to add keys. You can get step-by-step instructions during runtime, but basically show, not tell, how things work, so that the end user has a working example rather than my description of a working example that they have to then translate to a working example. And I think it's incredibly useful, especially when you're dealing with signing keys and signing things, and there are a number of ways to mess that up. So having something that works as a reference is incredibly useful. And speaking of keys and security, easier encryption would be nice as well. Now again, end users will do this differently. Manufacturers will have protocols in place for hiding, putting their keys someplace secure, dealing with signed binaries. The individual implementations will be different, and I encourage them to be so. Have security people look at this. That's what they get paid for. But for purposes of demonstration, ONIE has an encryption directory where, like emulation, there's an ONIE encrypt script which will handle generating a bunch of different keys in a bunch of different formats so that you can play around with them. It will do things like store the UEFI script, the right keys, NSH there for adding keys. And if you've got something like a signed shim, which is sort of an outlier in build, where typically the shim has your key in it for secure boot. You send that off to some entity whose keys are on the BIOS of the devices you to be running on. They sign it, bring it back to you, and you never rebuild it again unless you have to for security or upgrade purposes. So typically you'd send it off to Microsoft to get signed by their key. Microsoft keys are in most PC BIOSes, would be the standard example of that. So that's part, you can build it, but it's not part of the build system. So previous ONIE documentation suggested storing that in a safe place, so the encryption directory has a safe place directory to put this shim that you'll build once. So speaking of secure boot, we now have security enhancements standard. It's been implemented with the x86 virtual target. It works with emulation to demonstrate it. It also signs the demo OS, so there's examples of everything you'd want to do as a manufacturer using the virtual target. It's gone basically down to a 4-step process where if you want to implement secure boot, you generate keys, build a signed shim, build the rest of ONIE, and then run it with the emulation, and you're done. And I've also got a tutorial video on this. I was thinking about including it as a demo, but it ran 35 minutes to be complete, and it's probably best viewed when you're looking at the code anyway. But I've got a link to that further on down. Additional features we've got, you can, as a compile option, you can add a password to ONIE, so people need a username and login to access it. And we've also implemented secure GRUB, which will validate configuration files, so if they change, GRUB won't load them and the system fails to boot. It can require a password as well. Again, that's all in the x86 example code. So this is what we've got. Now, how do you go about actually adding it? So for security, there's now a machine security make file, which sits alongside the machine make file in your target directory. The machine make supplies a bunch of particulars about the platform you're building for. Machine security does the same thing, except it's just one stop for all of the security settings that we're using with secure boot. There's a one-to-one mapping of files that get signed with keys, just so that it's very clear. It's everything you need to do to implement the feature, just put in one place. And again, the real-world implementation of this is probably going to look different. It probably should look different. But at least you have an example of what this is all supposed to look like. Importing this, do look at the ONIE git commit history for the features. While the documentation is currently lagging, the git commits are not. There's a ton of information in there, including some test cases for the feature, a description of what's supposed to be happening. It should really bootstrap things pretty well for anybody coming into this cold. I'd also like to add a shout out to Andre and Michal from NVIDIA. They did the heavy lifting on these features. I just prettied them up and upstreamed them. But it wouldn't have been possible without them. So that's what we've got in ONIE so far this year. Now, the immediate future, what are we looking at? Well, continued maintenance, more bug fixes, fixing pull requests. Although I will say it's been kind of quiet out there. When I introduced the changes for a component upgrade, I expected to hear either cheers or screams, and I haven't heard either. So let me know how things are going on out there. We've got our project meeting every third Wednesday of the month. We've got the OCP ONIE mailing list. My email is all over the code. I'm just curious how everybody's doing out there. And it's always, tough to get feedback remotely, but especially so with a pandemic where everybody's been spread out. It's been difficult to read the room. So anyway, future projects. Probably the next thing that would be nice to have is a secure installer so that ONIE can download the installer and then validate it against the keys that it's got in its repository to know if it should even try and execute this code, because apparently downloading things off the internet and running them is not a good idea when you're not in the middle of a data center. And it can be debatable even then, I suppose. But that would be nice to add. I know there's some difficulties there. There's an initial spec for that hasn't been fully fleshed out. There's going to have to be some component upgrades because I know there's some problems getting keys out of the BIOS with the components that are there right now. And it also has to run in a sort of a shell script to be able to validate things because that's the installer. But whoever gets the good code in first wins. So I'm looking forward to that. Beyond this, we're working with the Open Compute Project Enterprise Connectivity Services Group, who will be speaking right after this. So if you're interested, please stick around for that. We're looking at using ONIE and network edge devices to be able to upgrade them. So this would include things like improved security, an updated build system to be able to introduce things faster, image upgrades outside of the data center where it would be going to a particular location to phone home and pull in its images, and adding Wi-Fi support because the device being upgraded might not be wired into a hard line. So if any of this sounds interesting, our status calls, like I said, are every third Wednesday of the month. The tutorial demo I mentioned for Secure Boot takes you from checking out the code to actually running it with the virtual target. I got a YouTube link for that. It is far from exciting, but I hope it's very informative. And for further information, there's the ONIE GitHub, there's our mailing list, documentation. There's also the Connectivity Solutions mailing list coming up next. And if you're interested in the build environment, which I highly recommend for building ONIE, the source for it is on GitHub there. It's MIT licensed, so there shouldn't be really any imperial entanglements in using it. So yeah, I think things are going well so far. I'd really love to hear from the community, but I think we've got a lot of exciting stuff going in and a lot of exciting stuff coming up. So thank you. Questions? Is there anybody online, or have I stunned everybody in the audience into silence?
Nobody online.
Okay.
I guess I'll throw my question, which nobody will be able to hear.
I'll repeat it.
It's mainly about actually being able to securely install the NOS
Okay.
from ONIE, right? Rather than curl or whatever, right? Being able to do that. Have we talked about doing that?
Yeah, so the question was, how do we securely install the NOS? Is there anything in the works for that? The secure installer would probably cover some of that. So the idea would be when you build an install image, it's basically an installer script at the front, and then the back half of it is a tar file with the actual data that you're trying to install. And so typically right now, ONIE if you do an ONIE NOS install, it pulls it down, takes a look at the image, executes the first part of it, and then the install script goes off and does its thing. Obviously, there are security implications there. So the idea with the secure installer was that the image would be signed at the back end so that the script at the front is still executable. And then when ONIE downloads it, it would know if you have, say, Secure Boot active, it can check that and then validate the image. It would pull a key out of its BIOS, use that to validate the signature on the image. And then if it passes, it executes it. If it doesn't, it does not execute it. And with this model, it also allows backwards compatibility. So if you don't have Secure Boot on, it will just take an image and install it. So the image format can stay consistent because a signed image can still be installed. Its format hasn't changed regardless of whether Secure Boot is on or off. And if it's on, ONIE will be smart enough to check it. So that was the approach I was thinking of taking because it keeps backwards compatibility, but still allows future expansion. I hope. So TPM has not currently been implemented, at least from the ONIE perspective. I'd probably have to take a look at the code to see how that implements in. I would think that'd be a little bit of a lower level hardware manufacturer interface, but there is no, at least concept in ONIE at the moment for TPM, I don't think. But again, I'd have to take a look at it. I'm fairly familiar with the code, but I'm not a complete expert on it, and somebody may be able to point out where I'm wrong there. And please do, I'd love to know. All right. Oh, yeah, question.
So the security extensions, they look like they're mostly x86 specific, because they're what kind of working genetically are.
Right. So the security extensions currently are only the question was, are the security extensions only x86 specific? Yeah, currently they are. So it's only been implemented on UEFI BIOS for x86. It should be extendable for ARM with UEFI, and then there hasn't been any work done on U-boot. So any security from that end of things has not been looked at yet. But again, I'm totally up for pull requests. Yeah. So, yeah, and hopefully the x86 emulation target proves to be a useful example. I was trying to think of everything somebody might need to know when trying to implement this, various skill levels of security expert to engineer who got assigned it. Hopefully it's pretty approachable. But I'm sure as we go into actually implementing this in real world systems, we're going to find difficulties, things that need to be modified, cases I hadn't considered. I mean, that always happens, so I'm prepared for it. All right. Well, that wraps it up. Thank you very much for your time, and I will yield the stage. Thank you.